In a previous video, I discussed the transpose of a matrix. We usually use prime or the superscript t to indicate the transpose of a matrix. In this video, we consider the transpose of the sum or product of matrices. For instance, we can take the transpose of A plus BC. Going back to our discussion of matrix multiplication, dimensions have to match. That is usually a good starting point to understand matrix algebra. Let's assume that A has the dimension k times m, where k refers to rows and m refers to columns. Thus the product BC needs to have the same dimension for the sum to make sense. Thus we state BC has dimension k times m. Let's have a closer look at BC. B might have dimension k times q, whereas C has dimension q times m. Again, there needs to be a match, as discussed in my previous video on matrix multiplication. So the adjacent dimensions, they have to agree, which they do. Both are q, and the outer ones, they determine the dimension of a product, as suggested k times m. Now, by definition, after applying the transpose, we should end up with the dimension m times k. So over here, we would expect m times k. Now the first term is simple. We just take A transpose, and to get the second term, we have to think about the following. So first I switch position. So you see I have now C times B, and looking at the dimensions, they would not match because now I have m here and k there. So to make it match, I have to take the transpose. So taking the transpose results in C prime B prime with dimensions m times q, q times k. So again, the adjacent dimensions match. So these two match. And we end up with the product of dimension m times k as intended. So going back to our equation, we have A prime with dimension m times k, followed by C prime B prime. So now we know how to take the transpose of a sum. We simply take the transpose of each term of a sum. And if we encounter a product, we have to switch the position and apply the transpose, as we can see in the equation above. Great, I see you next time.